Hello, people. Wait. Let me reopen. I have to reopen my chat pop out because it was showing me the other channel's chat. But the name Sidney reminds you of the Pretender series. I don't know what the Pretender series is. I do know that we very likely have an operator precedence problem in the compiler. X is 7. Now let's make it 8. Y is 1. So A is going to be minus X or Y, right? B is minus X or Y. C is minus X or Y. Right? That's what we want to know about. That doesn't seem good, does it? I think most people would think that unary minus is closer than bitwise or. Or even, in fact, Boolean or. Does anybody disagree with that? It should be according to the table you're looking at. Yeah, well, I mean, the C operator precedence is always going to be a little different. Like, there's some things that we want to fix, but this should be closer. Unary minus is as close as it gets. Yeah, I mean, can I think of anything? Like, what would I want? Yeah, no, like unary minus, yeah, it should. Okay, so the question is this happening because the number is just incorrect, or is this happening because we don't associate unary minus correctly? And in order to answer that, I'm going to get... Actually, you know what? I'm going to cook an egg sandwich while we do this, while people show up, so that I have calories. We have eggs on the stove, especially when applied to a constant. Yeah, well, let me look at the weird way that I do this stuff. Okay, we have binary operator precedence. We have unary operator precedence, which is, I mean, I don't remember if these are supposed to be in the same space or not, so let's start there. I mean, it looks like maybe we do it. Okay, what if I just jack this to like minus -27? That's a very well-defined and not at all arbitrary number. I don't know what you're talking about. Binary not. What is binary not? You mean XOR? Had that solution open in 0.5 seconds. Well, it's not a big solution. Okay, that didn't change Jack. That didn't change Jack diddly squat. Bitwise not minus or bitwise negation. Oh, so like tilde and C. Yeah, but you can tell the order of that just by, because they're both unary operators, so whichever one is closer is the closer one, right? So I guess the next step is I just want to I want to step in there and like see what's going on. Because maybe well, I just want to look at it. I just want to look at it. right, everybody, we have a fabulous egg sandwich with turkey slices and Havarti cheese and pickles and stone ground mustard. Or no, what do you call it? Like it's the whole seed mustard, you know? And mayonnaise. Yeah, you know, for cheese, I most frequently do like pepper jack or Swiss, but I decided to mix it up today. Because that's in life, you can do different cheeses. That's the thing about life. You don't have to do the same cheese all the time. This is honestly a really good sandwich. In San Francisco, there are like sandwich places where you go there and you pay them $12 for a sandwich. And like, I don't know. I mean, they're about as good as my sandwich that I make at home. So we're going to go line 7. Okay. This is an old breakpoint that we do not care about. In fact, almost all of these breakpoints we do not care about. Okay. It's a unary operator. My precedence is minus 27. Wait, is minus bad or good? Hold on. Actually, I think we want it to be very high, right? Hold on. What does low or high mean here? I don't even know. I don't know what low or high means. I don't know anything about computers. I think it's actually higher is tighter binding, right? Because this is -3 and less than is -15. So really, this should be 1027, right? Does that make sense? It does make sense. So what do you guys think? Maybe it doesn't need to be 1027. Like maybe this could be 1026. It could be 420, 2077. I mean, guys, we want our compiler to actually work. You don't want to take it in the wrong direction. You know what I'm saying? I mean, like all elite social media influencers, I have a very high-end team of people working on my brand identity and my graphics. So this is the result. Do I think the engine tech is impressive? I mean, all I remember is the demo that I saw like 2 years ago, and it was fine, but I didn't see anything in the way of like impressive engine tech. Like, but I might not be aware of what they're doing. Never mind. I'm not even going to ask the follow-up question because then we'll be talking about this game, which I don't want to do. Wow, you're really bringing in the Putney Swope quotes today. Maybe we should do a Putney Swope demo video instead of a Sidney Coleman demo video. I probably would get banned from Twitch. But you know what? At some point, it's okay. I'll just make my own streaming platform on my own OS. It's fine. All right, so I think like we want it to be less than 20. Because if you say minus a dot b, or no, it wouldn't be minus. It would be like minus dot. Wait, these don't unary operator precedences don't interoperate, right? If I say like minus a dot b, we don't want it to be minus a dot b. We want it to be minus a dot b. So we actually want binary dot to be tighter than unary minus. Same with array subscript. But actually, let's make it 4. All right, so tighter than bitwise ops, looser than array subscript, right? So for example, right? So if we say minus array sub 2, we want that to be like minus 4, not minus array sub 2, right? That would be bad. So it's not actually tighter than everything. It's just tighter than the usual operators that you think of. So I'm going to put this in a test, by the way. Whoops. D is minus. Why did I say 2? That's the array index, bro. Learn to know the difference between the array index and the result of the computation. Okay, so I'm going to put this in one of our tests in case we break it. Wait, did we have procedure call? We'll see how that shakes out. Okay, do I have MISC? No. This is just where I put tiny tiny things. Unary minus precedence test. There we go. Now we have another test, and that is good. Fixed, unintuitive, and error-prone precedence of the unary minus operator. Okay, so now let's just see if Sidney comes out better. He might come out the same. Whoops. All right. Okay, he's coming out about the same. I deleted all the files. So these green files are new. They're very cyberpunk. You might say that this is what Sidney looks like in the year 2077, all right? Maybe. Why are these out of order? Like what? All right. So as we see, okay, this is, oh yeah, it's the 12s. 12 is fine, and then it gets worse. Okay, so great. That may not be, there may be another precedence problem. But I should be able to go to video here and change this back, right? And hopefully it should actually work now. In the sense of, yeah, so we're still good on 12s. We're good, 12, 24, 36. That's all good. It's the deltas that are wrong now. I don't know how to debug that. That's going to be annoying. But it is like macro block deltas. So like that would be right here, wouldn't it? Do prints need removing from test? No, I like leaving them in there. Has anyone else noticed? I know someone reported a while back some operator precedences they thought that were weird, but I don't remember what they were. I think I filed it under problems to think about later. Expected shift error in the macro blocks for CBCR planes. Yeah, I mean, it does seem like a block level problem, not a pixel level problem. Although there could be a pixel level problem additionally. But this really does, this just looks kind of like a signed, unsigned problem in the blocks. Like, I don't know. Okay. So is it B frames? Are those the delta frames in this? Because what I could do is I could do 2 frames. Right? I could do, we could go directly to frame 12, right? And then we know that's correct. And then we could start decoding frame 13. Right? I mean, that sounds reasonable. How do we find the problem? I don't know, but let's try that. The frame right before the iPhone. No. So we are dumping 2 separate images. We're dumping the full color and the luminance image. So each pair of these corresponds to each other. So the black and white, don't worry about it. The black and white is correct. What is not correct is the blockies. It does look like there is a pixel level problem. Okay, well, this is interesting, right? So if we look at 13, so right, 12 is good. 13 is kind of jacked. 13Y does have problems, but not nearly as many problems, right? So there's some kind of issue in the color channels, right? Like most of the problems in the color channels. Do you see lines of different intensity on the macro block borders? It's hard to tell. I don't really, but who knows? It just looks more like the DC component of the macro block is just messed up. Yeah, I don't see any kind of grid effect. You know what? I should, before I do anything else, just make sure the game runs. Because, like, I did just change the precedence of a basic operator. So, like, let's just, before we go any further, let's just see what goes on here. Okay, great. Great. So, well, I don't know what macro block intro means. Like, I think I can get rid of this, by the way. We could put one there, though. Make sure that works. Yeah, so we're fine. Record the macro block coordinates of a bad macro block, and then if it's the broken block, ASM int3. Yeah, I don't even know what the coordinate system is here, though. Like, I guess it starts at the top because it's a full block up here and a partial block on the bottom. So we could go 0, 1, 2, y equals 3 and x equals 0, right? That's a broken block. Oh, it zigzags the block. Oh. Oh, dear. I mean, maybe I messed up the zigzag array thing, right? I did do some stuff there. Right, so this thing, I don't know what these numbers are. They're indices into the other matrix, right? Maybe that's not the same zigzag that we're talking about. This whole like non-intraquant matrix, you could just bake a version of the function that takes a constant 16. Try writing red to a block. Okay, here's what we're going to do. We're going to go back to our program. We're going to change a little bit what it does. We're going to go if index is equal to 12 or index is equal to 13. Then we're going to save the files. All right? Otherwise, we won't. So we don't have to get a whole mess of files anymore. Right? So we're just going to get 12, which would be correct, and then 13, which would be incorrect. Right? And assuming that that's right. Okay. So 12, 13. Great. Very good. Very, very good. Let me delete some of these old test files. I mean, just more. I guess just more things are going to come on the screen, but whatever. Whatever. Okay. So let's look at what we would color red, right? Let's figure out what the code is. It would be like, isn't it predict? Predict macro block, right? Like, why are these constants on the thing? Why aren't those just parameters? Okay. Saving registers makes the codec fit. That's not. I don't know if I believe that in a case like this. Like, there are so many things about this code that could be made faster that are way bigger than that. Like, that is so far down the list of things that would matter. So far down the list. Okay. The Java guy probably copied. Yeah, I mean, on really old computers, it might be fine. No, like what? Like the fact that it's unpacking the data from the buffer bits at a time. That's absurd, dude. That's just not how you do anything if you want it to be fast. It's fine for our purposes right now because we just want to get this working, but that would be the first thing I would change if I wanted this to be fast. Okay. Video copy macro block. We could make a stomp macro block or whatever. I don't know what this H and V are. Are those coordinates? Or are those like vector components? Motion H and motion V. Motion H, motion V. No, the row and column. The HP Lovecraft by Hewlett Packard. Okay, this is the source coordinate. So these are indices into like a motion vector buffer or something, but that's not necessarily macro block coordinates, right? It's just the MB row and MB call. Let's do this. How is this? If MB row is equal to 3 and MB call is equal to 0, then we'll block set, oh, because DI and SI. So we're going to set this to 255. All right. Okay. See that? We got the right stuff, I think. Okay. Now, interestingly, I expected that to be fully white, but it's like, whatever. Yeah, if I had done a more careful conversion, I would still be, I wouldn't have anything on the screen yet. It is cyber pink. You're right. It's cyber pink. That is exactly what color that is. It's cyber pink. Okay, but we do have the right macro block that we care about. Well, we could just see what the deal is in both of the programs again. On frame 13, right? Row starts with 1. No, it starts with 0 because we hit the right block, right? If I go 4 here and we do it again, it'll be the wrong one, right? I have to go get it again. See, now our cyber pink is 1 off. You want the cyber pink to be on that green square. That was the goal. So it's definitely 3 and not 4. All right. So the cyber pink. So basically, instead of doing this, right, which is not our goal, what we want to do is understand like what is even going on here. All right. Now, is it... All right. We'll just do this. And we don't need 2. We just need 1. Yeah, I mean, my goal, the reason I didn't do a very careful port is I don't want this to be the C version of the code, right? I want it to turn into what is best for this programming language. That's how you figure out what the language is like and how, what it's doing well and what it's doing poorly. So, feel very Java Rust today. Well, that's great. That's great. Okay, so we have this, and then we want to put that into the C version. Right, so we want up here same thing, except it's self and not video. And we need more parentheses because it's C. And we want to say int k equals that. All right. So now I just have to figure out. Okay, that's great. And that's great. So, now we need, though, we need to go here. We're going to go back to this. And we're going to make our program do the following. We want index 13. Yes. All right. So that's in that program. All right. So we're going to go here, and we're going to go break here. All right. Those were old breakpoints that we don't care about. All right. So we're at break here, and now we want to go to int k equals 1, 2, 3, 4, 5. Okay. So here we are in the C version. We're in copy macro block, predict macro block, decode macro block. So I guess we're actually, see, Visual or the C compiler doesn't really do the right things, I guess, about telling us what line we're in. But we're actually here in 3026 because we're calling into predict macro block. So we set these three things to 128 and then went in. So it's likely that the bug is like below this, but who knows? Okay, so now we do the same things on the other side. We go to here, we say right, and then yeah. Okay, so we rebuild this, and in the other, look at all these windows, guys. Okay, science and technology goes away, that goes away, that goes away. That's gonna go away. All right. So we're going to break there, and then we'll set something in video at here. Right? So we're here, and then we go there. So I don't know what to look at. I mean, we could just go down to the... Let's look at like motion H and motion V and I don't know, DW, that's fine. We'll look at the source data. Oh, look, it's periods. Okay, so back here in the other thing, source data is also periods. Okay. Motion H and motion V. 10, 0. Okay. So it's probably just to do that we have another math screw up similar to the previous one. Odd H, odd V, 0. So it's the same case. It's just this. Really? Really? That seems weird. See, the problem is this is going to change. Why didn't that change? Oh no, because it's d plus di. Whoops. Whoopsie. Let's do this again. So we're just going to write down that number. We do this. Okay, so d of 23040 is 18, as it should be, because we copied it. Oh, you know what? We're in the Y channel right now, guys. And the Y channel is not really the one that had the problem, is it? Let's verify that, but... Yep, we're just changing them from 17s to 18s. That's great. Okay. We want to look in CR and CB. Actually. Does Remedy not have a locals tab? I never use locals tabs. They're always annoying. It does. It has a way to print locals. I just don't use it either. Optimizations with pointer what is pointer provenance? Passing the wrong arguments to PLM block set. According to who? According to who? We talked about this last night, guys. It's fine. It's something to do with tracking the original allocations so you can do optimizations with pointers. Well, if you don't even know what it is, then why are you asking me about it? Curious about my opinion on it. My opinion on it is all this aliasing stuff where they try to get you to conform to really weird rules that almost no program in the universe actually conforms to if they wanted to, which they don't. In order to make things go slightly faster is complete nonsense. It's much better just to have way fewer pointers in your program to begin with, which you would do if you didn't drink the object-oriented Kool-Aid. You don't have pointer aliasing problems if you don't have pointers, guys. Okay, so I am not sure. I guess I'm going to step through into the color things. Actually, okay, so DI here is 23040. But DI for the color channels is probably like a quarter of that, right? Let's go to the C version here. Where are we? Right. Self MB row, self MB call. Yeah, so we could have just continued through there. I don't know if I stepped through the green panel and went to the blue panel, whatever. Anyway, DI is 5760, yeah, which is 23040 divided by 4. So we could just look at the result of, I guess we're in this one, right? So if we're up here, what is S, or no, D, cr.data of, what was it, 57 something, 5760. 129. We can see if that's the same. Not the same. Good. We have found a thing that was not the same. That is progress. We're going to restart. We're going to hit here. We're going to go back here. This is the luminance. Now that's the chrominance channel. And we want to get there in the C program again as well. So we take this out. We go to there. We go back here. Luminance. Now it's the chrominance channel. Okay. Let's see. Motion H5, motion V0. Same. S is a bunch of dots. SI. Okay, let's SI, DI, S of SI. I don't know, like, in theory, these variables are not defined at all yet, so why are we getting the same results in both of them when we're not even, like, that's a little bit humorous, by which I mean part of my leg. All right, so S of SI is 129. S of SI is 1. Really? Well, that means the problem happens before this, right? So, wait, SI was 5762. S.cr.data 5762. Arrow somewhere. Zero might be fine. Wait, what? Wait, what? Okay, guys, this is really confusing. Here we have S and then D, which I take to be source and then destination. Here we have D and then S, which I take to be destination and source, to which I ask WTF? WTF. It's probably the same here. D and then S. S and then D. What? It's fine. It's fine. It's just confusing. It means that we need to check not S on this frame. We need to check D on this frame, which is S in the other frame. By the way, never write software that does this. It makes it so hard to understand. It makes it so hard to understand. I'm going to put that in the notes. Understandability. S and D swap in the call to video process macro block. Very confusing. And the caller is probably the one with the wrong name, because this is destination and this is source. When you have an argument, is that a pointer or reference? That's a pointer. References, look, references are pointers. They are the same thing. They are not different. Okay. So we really want, when we were checking these numbers, we want this on D. And to go up a stack. Okay. This is already wrong, I think. So this is 129 in both of these. This one is 1 and 129. So the CR frame, the red channel is not right. The red is too low, which is why it's coming out green. Actually, that makes sense. If red and green are both too low, or red and blue, sorry, if they're both down, you're going to get green. Okay. Where do these come from? So by the time we go to copy macro block, it's too late. This is, again, I don't know who would have set these. Okay, we set the row and column up here, and that's being used to do whatever. I assume it's in here. Is it in decode motion vectors? I don't know. Could set a watch point. I know. I did that in the previous stream, and that is what ended up working. It's just, I mean, I kind of want to not have to do that again. I kind of want to understand the code better, but maybe that's not where we're at. But yeah, that's the way that I found it last time. So maybe we should just do that again, if we're being honest, right? Any reason I'm debugging this using a debugger? Yes, because I want to actually solve the problem for this case. Some things are better with printf. This is not one of them. This is not one of them. So decode slice. I think what we did before is we started before decode slice, right? Way up here. Okay, what is D down here? What would we set the breakpoint on? D is the frame. Gee, that's makes sense. Like what? So this is self frame forward, right? So so when I'm down here, yes. So it's frame forward in the red channel, coordinate 5762. All right, so we can go way up here to decode slice. What's it called again? Didn't I just type this out? It's whatever forward. What, guys? What do you want from me? Self frame forward. All right. So Okay. Now, what I want to do is I want to validate this by going here. Okay, we're at our breakpoint. Oh, wait, no, wrong breakpoint. Here we go. We're at the right frame now. And I want to go to the slice thing, which it... Here. Let's break here. Oh, it's already set to 1. Does that mean... Guys, I don't know. Actually, let's do this. Bro. Seriously? Oh, guys. Rip. Who sees what's wrong with what I'm doing right now? That has wasted an entire half an hour. Anyone? 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 So in this program over here, when it's... Oh, no, I'm just stupid. I put the breakpoint after the decode video. I thought it was before decode video on this one. Then I was going to say, oh, it's wrong that it's after decode video here. It's after on both of them. We've already decoded the video that is wrong, the video frame that is wrong, and I'm trying to find where it goes wrong. Okay, we established that frame to RGB. Anyway, it's decoding the video that is going to be wrong. Okay, not the RGB conversion. It's like I'm dumb sometimes. Okay, let's get rid of this. Still got Sidney. Same blocks are wrong. It's all good. Okay, so now we're actually going to do the break here again. We do know what to look for. We do know that this ends up being different, but I didn't really waste half an hour. That was a lie. Okay. Well, it's 129, right? And then we decode video, and it's 1. So let's actually use the data breakpoint now. Now we can do that because it's not preemptively 1. OX 1D78E41C902. 1D78E41C902. Okay, we're in a block set. And copy macro block. And okay. So let's look at which case we're in. Interpolate. It's going to be false. These are both going to be... oh, no. Oh, because it's divided by 2, so it's different. It's different. So it's this one. S of SI. Fiddlesticks. This is bad. This is bad. Because we're getting a 1 because we already had a 1 somehow. Dude, I hate this S and D swapping thing. I'm going to punch the monitor because this is so bad. So it's S down there. It's D up here, which is a frame. All right. Wait, what? Hold on. Down here, it's destination source, right? But wait, didn't I set the breakpoint on? What did I set the breakpoint on? 1C902. I can't see the addresses of anything right now for some reason. Why not? I don't know. So D is video frame forward right now. Wait. But we did a breakpoint on when does that change, right? No, this is a totally different... Did I just do the wrong fucking thing? What was I even doing? Like, when it's so messed up like this, I have no idea what I'm even doing. Like, it would help if variables were named consistently. I wouldn't have to remember as many stupid ass things. Like, at this point, I have no idea what I was even doing. We started up here in the program right? And then I set a breakpoint for frame forward CR data. Okay, but frame forward probably got reassigned at some point, again, because this program is an asshole and it does that all the time, right? So that's probably not the right breakpoint. Yeah, see, this address is different now. So either I was really stupid and typed it wrong, or it changed. It probably changed because we said frame forward equals something else, and that changed the data pointer. I'm tired for a minute. I need some chocolate. I don't know what to do now. Basically, we could try again after. Okay, we need to try again after we set the frame, because it like does like a frame swap, right? Okay. So video decode picture. I never could tell looking at this what it even does. Okay, here. See this part? This assigns frame forward. Yeah. So after this, we could do the breakpoint. Except it's already 1. Okay, that actually might be the useful information that we need to know. I need to get some chocolate. This is the worst part about debugging, right? This is what takes all the time, is when you don't understand what the problem is. As soon as you understand what the problem is, it's usually not that hard to fix. The problem right now is even figuring out where the problem is happening. And that, when people ask me, what debugging features would you really want? It's that. I want something that helps me with this kind of problem, okay? If you cannot help me with this kind of problem, don't come telling me how awesome your newfangled debugger is going to be, or whatever the hell, right? Like, this shouldn't be that hard. It's a giant waste of my time, honestly, to be doing this, because the computer should just be able to tell me what the difference was. But it doesn't, because the computer's an asshole, so I have to do this. What would it be specifically? Like, I just need to be able to see what this program is doing. Like, I still can't tell what it's doing. After hours of debugging it, I can't tell what it's doing. That is the problem. It's especially bad in this program because it keeps juggling around buffers between different pointers and like trying to figure out how did this value become a 1 is really annoying. But why can't I just ask that? Why can't I just say, hey, how did this value become a 1? And it would tell me the line where that happened. Would Mozilla's RR help here? No, it wouldn't. All right. We still can't set a watch point. The problem is I don't even know where to put a watch point yet because the memory keeps moving around and the program's an asshole and the computer's an asshole. So as nearly as I can tell, the problem is that in frame backward at some point, this 1 is in there instead of a 128. I don't know when that happened. I have no idea because these keep moving around and like whatever. So like right now, there is no place that I know of where I could set a watch point that I know would go off. If I knew that, we would be making rapid progress, but I don't know that. Data breakpoints are for that. Dude, I use data breakpoints all day. That's not what I'm talking about. I'm talking about memory. I want to know after the fact, because the problem is I don't know. So data breakpoints are great when your memory is very stable. It is not here. Things are getting moved around and whatever. So like what I want to know is, hey, computer, you're good at record keeping. Keep all the records of how this thing got to be what it is right now. Even if that's very slow, it would have been faster than me sitting here do this for hours. Just like tell me, hey, this memory location's a 1. Why? Tell me why. Why is it a 1? I don't know. I'm spending an hour figuring out why a certain byte is 1. Like, I'm spending an hour figuring out how to even know who caused something to make that byte be a 1 eventually. There needs to be some info from the compiler too. I mostly disagree. I mean, I think information from the compiler can help, but I mostly disagree. I think it can be done completely by the debugger. There might be some weird cases that it wouldn't handle, like, I don't know, like if the operating system intervenes and changes something when you don't have the ability to see that, but For a normal program like this, it should be fine. I'm not talking about time travel debugging either, guys. I'm not talking about time travel debugging. Okay, we've got some new tea in the pot, so that'll be good. Yeah, we could do the trillion printf thing. We shouldn't have to resort to that, though. Although, because we know which frame is going wrong, it's not as many printfs, because we could just turn the printfs on when we hit that frame. We could even just turn them on. Well, I don't know. Okay, so my problem is here, when we say video frame forward equals video frame backward, video frame backward already has the wrong data in it. And we can verify that in the C version as well. All right, which we haven't even run in a long time, but here we go. So frame 13, and is this the same place? This is in video decode picture. This is in video decode picture. So we're going to run to here, and there, I guess. 129, yes. So the problem is now, how did frame backward get filled out? I have no idea. When? When did that happen? Did it happen already at the breakpoint? Like if I do this, and I say PLM video decoder frame, yeah, okay. So let's see if it's already wrong there. Because then I almost don't know what to think. Because frame 12 came out right. Okay, actually, this is good. Wait, oh, frame backward. It's already wrong. So is there some, okay, the hidden assumption so far has been that the problem happens on the first frame that we decode. But like, is there additional data in the previous frame that we rendered that looked fine? but that contains delta information in some way. I would have thought that would be in the next frame. You know what I'm saying? But we have an unambiguous problem here. Okay, so frame backward. Let's delete all this other stuff. Frame backward has a value of 1 here. All right, before we even go into decode video. So this is left over from the previous frame. Frame backward here is 129 in the C version before we go into decode video. So it's in frame 12 that the problem happens somehow, but it's not visible. Like what? You know what I'm saying? Maybe it's a wrapping error because of no integer promotion like yesterday. It could well be. It could be really anything. I'm just trying to figure out what part of the code it's even in, right? I just want to know where is the thing. The problem is, again, you can't just check for this because the code swaps around what's frame forward and frame backward and all this stuff. So I can't just go to frame 12 and look for frame backward because that's going to get reassigned. So I literally don't know how to debug this now. I mean, okay, so we could set a breakpoint at the end of frame 12 after everything has happened, right? Or after framed RGB, or potentially even before it, right? Frame backward should have the incorrect value already. And then I could go to the beginning of the frame. I could try to figure out the mapping from before and after of which pointer it is. Yeah, I mean, since you talk about sign bits and shifts, that sounds very likely to me to be the kind of problem that this is. Like if you imagine a right shift and you shift down zeros instead of ones, like that is definitely the kind of thing that could do this, right? And it's interestingly, it is sort of in the brighter parts of the image mostly, right? Not really in the shirt down here, but that could just be that the shirt didn't change enough in this frame or whatever. So another strategy would be to give up on what I'm doing and just go check all the shifts. Like, I don't know what's going on there in the Y channel, but here it definitely... It's just a little sus that it's all on the dude. That said, that might not have to do with brightness and just like that's where most of the motion is right now, right? Needs mustache debugger. Yeah, sort of. I mean, what you want is the nice version of mustache debugger, like in your debugger. But also, I don't know. I never use mustache, so I don't really know what it does. But like, what I want here is not something even more serious than mustache, right? Okay. Since I don't know what to do, and we have about an hour left in the stream, let's try this. So we're going to go to frame 12. We're going to do one there for index 12, and we're going to do one here, and then we're going to do one here. And I just want to see what happens to the pointers, etc. So we're going to go there. Why is it breaking down there? What? See, as soon as that happens, I can't trust anything. All right. Anyway, so frame backward. But the buffer is probably going to swap at some point, right? So this is BD80. It's got 128s in it. We decode the video. What is even going on? Now it's right. That seems like a remedy bug. That seems like a bug where it thought it had the thing loaded, but the timestamp was a little old. I don't know what that was. That seems like a remedy bug. Oh, it might have been that I had it open. It might have been that I couldn't write. So sometimes when I can't write the executable, sometimes I don't notice. Oh, yeah, see? Because we had it open in the debugger, and so this failed. We need to print like a giant red banner when this happens, because it's very easy to miss. All right, so that was not a remedy bug. That was Windows being an asshole and not letting you write an executable that's open. Okay. So, in frame backward, but the data is frame forward, and then frame current is the other one. What is it? Frame current. So these just get cycled, right? So probably frame current becomes frame backward later. Who knows? Anyway, so we're going to decode the video. And now it's 1. Oh, but it's changed. Yeah, see? So I assume that was frame current. Let's figure it out. So we're going to start again. Frame current is BD80. So now we're going to go step forward. BD80, yes. So now the question is, can we do this with frame current? That will let us set our data breakpoint right there. Okay, we got you, jerk. OX1803B74D402. B74D402, yeah, probably. Okay. Run video copy macro block, video process macro block with, let's check the things, odd H, odd V. Here's, oh, no. Oh, we're good. Because last time we looked at this, we were like, oh, we're just copying from a buffer that's messed up. Now we're not. So odd H is 1. You know, it's probably literally this shift or something. That's going to overflow. We're overflowing where the C code did not necessarily overflow. So it's, I should have thought about this. So it's 129 plus 129 plus 1 is 259. Guess what, guys? If that wraps to 3 and then you right shift by 1, you get 1, which is the answer that we are getting. If it does not, you get 129, which is the answer the other thing is getting. So this is very confusing. So the question is, why does the C code not wrap here? Because the C code process macro. You guys see what I'm saying? Okay, so the C code basically runs these macros where it's like S sub Si. It's doing all these same operations, but like S is a uint 8 T star, right? So S sub Si is going to be a uint 8. So why does this not overflow? Promotion on shift. What? No, the problem happens before the shift, though. The problem happens, maybe it's the +1. This is really ill-defined no matter what. Okay, so if you say that the +1 promotes this, it depends on what order this happens in, because this would overflow as a U8 and then add 1. So even if this turns it into int, you might overflow and then add, because the order of addition is not defined, right? I know 1's an int, guys, but you see what I'm saying. Like, it seems like there are two interpretations of this. One of them is, oh, let's promote this to int, and then this is int, so let's promote this to int. Oh, they're all int, right? But another one is, let's do this addition. Those are both U8. Oh, it overflowed, and then do this addition. Oh, that's an int, so promote the overflowed U8 to an int, and then do the add. This code is bad. This code is undefined behavior, bro. U8 plus U8 promotes to int before the addition. What? According to who? That's not right. Is that right? Is there something weird about C U8s that I don't understand? This is not what I would expect. Like, if I was writing code that added two U8s, I would not expect promotion to int. In fact, that doesn't make sense, because if you promoted to int intermediately, it's still a U8 result, so it would have to truncate. Okay. Implicit conversions. This is already unreadable, dude. Okay, hold on. This is completely unreadable. This has nothing to do. This is all for like literals, whoever linked me this. Like, let's look at this link that someone said. Char C1, C1 equals C1 plus C2. Integer type smaller than int are promoted when an operation is performed. What? What? Oh my God, it's always intermediately an int and then it truncates. That is nutballs, dude. I32 equals U8 plus U8 does not wrap as a U8 in C. I literally never knew this about C or C++. I probably did know this a really, really, really long time ago. Like in the 90s, and it's been so long since I've ever thought about it that it just, wow. Okay, well, I learned something new or old. Yeah, so this probably doesn't overflow in the printf, right? How do we run it? Run. Boy, that was fast. Yeah. So printf is weird. Printf has its own stuff, right? So it's varargs, and things in varargs and C all get promoted. So this gets promoted to int no matter what. But I guess, okay. So I'm going to have to think about this in the long term about what the rules should be in the new language, because I can't say that I really like the C version here. I can't claim that I love it. So let's just try some stuff here. So the thing is, it's going to be a little bit ugly to do this, because no matter, I'm just going to put some casts on all of these just to be safe. And this is going to be super ugly. And then we're going to decide later on if we want some other thing for this. I'm not even trying to minimize it. It's just like as many frickin' casts as we could put. So that might introduce a type error later as well. Yeah. So we want to cast trunk to U8 there. Whoops, we're still running it in Remedy. That is one thing that Unix has always done well that Windows does not. Windows is very chill about just letting you write a new executable. All right, what's our Sidney status? Where's our folder? Guys, look. Sidney is not perfect. Sidney is not a perfect human being. But you guys effed right when I pulled up Sidney, okay? The internet could not handle how well Sidney is doing right now. Look at this. There's just a couple of squares. Okay, let's turn back on the writing out all the frames so we can see the new status. I'm going to put in here, clean up. All these casts are really ugly. This has to do with the integer promotion rules here being different than they are in C. This is something to think about for sure. I'm not sure if the C ones are a good idea, but there's also this question of like, if we induce a lot of friction in cases like this accidentally, it's not good. Okay. I don't actually need all of these. So like I could just cast the middle one, sort of, except, I don't know. It just, I should really do these too. I mean, it's not going to matter, but we're going to do it. Make the compiler error or warn when the situation happens. The thing is, you can't really do that because the whole idea of having these sized calculations is that people maybe want to do that, right? I don't know. I definitely need to think about it. The two bugs so far have to do with differences between C and this programming language. Yes, but like that's what happens anytime you do something new is you like, yes. I mean, the solution to that would be just make C so that, but why would you do that? Although actually the other bug, the unary minus, was not really a difference in the language semantics. That was a bug. That was just a bug in this compiler's preferences, priorities. Could have an I'm porting C, please warn me. That is true. That is a thing that could work. You also remember rename bugs. Yeah, but that wasn't a language difference. That was just me aggressively renaming things, right? Like I almost had several rename bugs, but I caught a couple of them. Promotions to int probably help with performance on MIPS, maybe. Anyway. Okay. So let's go back. I just want to get full stock of the Sidney situation now. We're going to Sidney stock right now. Sidney stock. All right. Okay, so like we're gathering some little, it's like Sidney with like an indie video game about squares that relate to each other in a family around him, you know? But it's pretty much Sidney going on. Will the remaining artifacts come down to overflow and shifts? It is quite possible that they will. Yes. I don't know what odds I would put on that. It's very suspicious that these are all perfectly square. I don't know what that means. They're squares of different sizes, which is weird. Oh, that's not square. That's a rectangle right there. They're mostly square. There's a big difference between mostly square and all square. And these are in the Y channel, at least. Maybe only in the Y channel. Like, oh, actually no. Because here, it's like we have two different sets of things, but they could be the same bug. These do kind of look like underflow, like these white squares. It's like you could imagine ringing around his shirt that would take it into negative numbers or something. I don't know. Are those regions that have been compressed lossily down to one color value? I have no idea. I don't think so. I don't think that's how it works. These gray blocks, these are not macro blocks. They're smaller, I think. Aren't they? But they are the same size, basically, so that's weird. Maybe those are macro blocks. No. Like these are... These are... The big color blocks are basically 4 times the size of these smaller ones, so there's that. Eight by 8 maybe. Yeah, 8 by 8 in the... Nope. Cursor keys are working, actually. It's weird that the Y image has more height. The Y plane image is rounded to the next 8 or 16 or whatever. So it kind of goes up and down as I go. Hey, Sidney, how's it going? Okay, so these errors definitely seem to accumulate. We just get new ones. That definitely looks like overflow, doesn't it? Or underflow. It's... I think I'm just going to go check some more things. You know what I'm saying? I want to check some more subscripts. It would be nice to have this in an editor with all the meta information so I could just hover over something and tell what type it is. Okay, so this right here, oh, this is an index. Never mind. S sub 0 plus 128, right, shifted 8. That is, yeah. Oh, look at all these. Oh, we have other calls to block set guys. Clamp of S sub SI doesn't make sense. Clamp makes no sense here. Okay. Yeah, these could have exactly the same problem as the other thing. Block here is a pointer to S32, so we don't need to worry about that. Well, let's just see. Okay, that didn't fix anything. We have one in frame 1. We could do the same thing where we go like, WTF is that? Can the compiler put overflow checks? It could. The plan is that we would have that eventually. We don't have it currently. We have cast checks, but not like math overflow checks, which is what we would need here. Have I ever tried the portrait monitor setup? Not seriously. Yeah, oh yeah, let's check for block sets. Good point. I was just saying we have other block sets. So these are these ones. I'm double checking these real fast. Clamped. That's already cast to S32. That's it as far as I know. Let's check and make sure there isn't one in like... Nope. Oh, here's one though. Right here. I'm just going to check. That was right in the middle of all the other stuff that I was doing and I didn't see it. Let's just look for shifts, because even though shifts are not specifically the problem, a lot of the time shifts are in the neighborhood of, oh. I'm going to WTF that. So this is all the stuff that we fixed. CoF, that's a 16-bit. That's, yeah. It's bigger quantities. CR, CG, and CB are 32 bits, I believe. Yeah, oh, they're right there. And that's it. So maybe that last one that I fixed was it. I don't know. Nope, didn't change anything. Let's double check by just deleting all these. I'm sure we didn't change anything, but I'm going to do it again. There we go. Yeah. Okay, you know what? Let's just do this because this bothers me. We're just going to do that. Okay. It looks exactly the same, but you know, well, is it exactly? Probably. Anyway, so we'll leave this because this is just way faster anyway. Or we're just not relying on compiler magic in order to make this good here. How quickly could you make a meta program just to check for C int from motion? It wouldn't be that hard, I don't think. It's just I don't want to pause in the middle of this and start an unrelated thing. Even if that unrelated thing might solve this, it's just the way. Part of what I do is like I stick to what I'm doing, you know? Okay. Well, let's just put parens here just in case. I don't think that does anything, but yeah. Okay. So well, we don't need this anymore. So it is very likely something like this, but maybe not. What could also happen is I rat hole looking for another U8 situation, and it ends up being something else, right? That could definitely happen. Are overflow checks difficult to implement? They're not hard to implement necessarily. Okay, so the problem is how do you know if you overflowed? And that depends on what the operation is that you're performing and so forth, right? And especially what your backend is. Like if I'm outputting x64 code directly, I could maybe check the carry flag or the overflow flag. If I'm talking to LLVM, it's like totally different, right? So it's just unclear. I haven't done it because it's unclear. In terms of how much performance does it cost for your program? Well, it doesn't matter because you turn it off for release builds. I mean, it matters, but you know, for a debug build, the goal is you can basically choose how much debugging you want, right? I will say that in promotion thing was subtle. Like, I guess I didn't know about that. Like, all right. So we could focus on the Y plane here. I'm confused by what I'm looking at though. Like what are these? These seem smaller than macro blocks. So who would be manipulating things? They're not even all like this rectangle is like a little bit short. What's going on there? And these two overlap a little bit. what part of the code would be doing this? Can be a macro block LUT error. I mean, the tables, if I think of anything, like the tables here, they didn't change at all, right? So like, I actually feel pretty good about these tables. Yes, if you add two U8s, the result is a U8, which seemed like the only thing that makes sense. But it does seem a little different from C. What about the copy of the table value into the frame? Which table value? Wasn't there a table that was 16 long but with only 14 elements? Yes, there was. I think I made a note there. Or was that? That might not have been in this file. Are we using macro block type? No. I think we can just comment that out. Yeah. Okay. So maybe check video interpolate macro block. I haven't even looked at that function. I mean, it just calls process macro block with interpolate set to true. Right? Okay. So in here, when interpolate is set to true, maybe I screwed this up, right? Or this thing had weird parens in it originally, and like I mean, we could again intentionally try to screw up one of these to figure out where it is, if it is this thing. Look at all this funny rounding. Funny rounding. What do we do? What do we do? What do we do? I mean, I'm pretty happy with the progress so far. I would like to nail this last thing. I would like to nail it because look, we almost have a Sidney. We almost have a complete Sidney. He's got some blocks happening. Would it be possible to color pick the image and break at the color output, then go backwards from there? If we had a good debugger, yes, that would be possible. Does cast S32 A plus B cast only A? Yes. Well, in theory, yes. Who knows, dude? We could put that back in this program. So we could say... A is a U8 that is 200. B is a U8 that equals 60. Right? R is cast S32A plus B plus... Trying to think of a thing. Well, we'll do like C, right? So R is 500 because it's 300 plus 200, right? If I did this, we're not going to get 500. Oh. But yeah, in this case, it is doing what it looks like it should do. Yeah, there is a leaf blower happening outside. Cache should promote the whole expression according to who? Why? Can't you verify the arithmetic with just compiling the original with prints to do the same here? Dude, there's like just crap loads of math. I don't know what to, like... I don't know what to print. I don't know what to print. Okay, question. Is it in the RGB conversion? And the answer is no, because again, in just the Y images, which are pre-RGB conversion, we have this problem. So it is in the D code. That's pretty good. I'm almost tempted to simplify this a little bit because these all use S sub Si, right? And then these all use D sub Di. It's not quite worth it maybe, but it would be probably more readable if I did that. Like, okay. Of course, I could break something here, but I would go SS is cast S32, S sub SI. DD is cast, whoops, S32, D sub DI, right? So, and then we're just cutting down on the amount of stuff. We still have to do these other indices, right? But we don't want to declare them up here because we don't want to do the work if we don't have to, right? So but in cases like this one, it's like suddenly more readable, right? It's like, oh, we're averaging them rounded to nearest, I guess, right? Whereas that wasn't particularly readable before. And then these are all these, but averaged with DD, I guess. Something like that. All right, Sidney. Wow, I really screwed it up, guys. What? What did I do? I mean, that looks pretty cool. If I'm being honest. Doesn't that look nice? It looks pretty great. Okay, wait. Okay, hold on. We're going to walk this back. Okay, Sydney's back. We still have some. I stopped it before we overwrote the later ones because that's pretty cool looking, honestly. But he's back to here. But this might be a clue because, like, what? You know? Like, if this makes a difference in the calculation for some reason, then I don't know what's going on. Right? Oh, no, guys. The problem is SI and DI change per pixel. I'm a dumb butt. Block set modifies SI and DI as it walks over the thing. So we're averaging these with the pixel like in the corner, which is why they look flatter and more averaged. It was pretty cool. Yeah. Okay. Somebody in chat said that too. Thank you. I figured it out though. I am not that dumb. I'm only moderately dumb. Oh, I almost knocked my teapot off the desk, but I caught it. Okay. Isn't it great when your visual screw-ups actually look like what they should look like based on what you screwed up? Is the array S modified in block set? No. What we do is we write to the elements of D in there. Dest, it's confusing because dest, it's all caps, but like that's D, basically. Let's make this not. Since it seems like this is how we're really going to want to do it, it's worth like committing to making it look a little nicer. Because, you know, in the original, it was like, I don't know if this is really how it's going to work, right? You know what? Let's leave that caps. Okay. Did the blocky version have the white squares? I think they did, yeah. Okay, let's do a couple things here. Just okay, I screwed it up again. I admit it. Wait, what? This is a different screw up this time. This is fun. Isn't this fun, guys? This looks like an Atari 2600 game, but with better colors. This looks like, you know, when the Italian lady in the church decided to repaint the painting, but like digital indie. What happens if I don't interpolate? That's a good question. Okay, wait, what I was trying to do... Oh, okay. So the problem is these code inserts depend on SI getting incremented. I was like, let's just put SI increment out of the loop. But, all right. Yeah, let's try turning interpolate off. There we go. We're back. We're back. No effect whatsoever. Well, I mean, no, it's about the same amount of stuff. But this is, okay, these things are smaller than macro blocks, so they're happening after, right? What happens after the macro blocks? We do this motion stuff, right? So read VLC returns S16s, which should be big enough to do anything we're doing here. Are the white squares in the same place every time? Yes, they are. Make a 1x1 MPEG and see which squares are totally messed up. Can I visualize the movement vectors? I don't know. I don't know, man. So this buffer read VLC uint thing is suspicious. You know? But maybe not. Maybe not. Am I sure abs M code minus 1 left shift R size does not get truncated as S16? Let's see. Just looking at this stuff again. Yeah, that's fine. Okay, M code is S16 because that's a buffer read VLC, right? S16 left shift R size, which is S32. Yeah, I guess that's worth trying. No effect whatsoever. Are the blocks really smaller than macro blocks? Yeah, I think they are. I mean, they're various sizes. Like, look at this. Although maybe how it works is it lays down a square and then covers up part of it later. I don't know. I don't know. Okay, this is a really interesting case right here because we have a block in the Y channel and then a block in the CRCB. And the block in the CRCB is very clearly, as they say in the business, hosed. We could try to zoom in on that one, right? Right? That seems like a good plan. Except that I don't have that much more time to go before I have to hang up on you guys. But I don't know how many over that is. 1, 2, 3, 15. Let's just try something. Let's go back to here. We're only going to output 5. Because that's where we were at. And we're going to go back to our hack factor. We're just going to find that block. And it's, I don't know. It's, oh, I deleted the code down here. You know, it's like column 14, I don't know, 14 in row 12. And it's block set. Oh, I need all this stuff. So we've got the orig SI and DI. DW, DW, block size, code 255. All right. So this should be our cyberpink again. And let's delete all of these. All right. So, wait. Did we rebuild? Why don't we see Cyberpink 2077 anymore? Okay, hold on. Let's make this for block 0, 0. We could be off the screen for all I know. That's my alarm telling me I have a thing in an hour that I need to prep for, but I'm irresponsible, so it's fine. All right. Dude, I don't see Cyberpink. What is going on? We could do this. I don't think that's going to matter, but why before we got Cyberpink 2077 when we set this and now we don't. I don't understand that. Wait. Oh, right. Sorry. That's why we didn't get Cyberpink 2077. There we go. There we go. We're back in business. So let's go to like 12, I don't know. Okay, so we need like 16 by 18. This is professional programming, everybody. This is like how you do it. Okay, so we need 2 and then 1. Okay, wait, we've got cyberpink in the neighbors. Is there some process that like fills the neighbors? Or is that the problem? Like we've got our block of cyberpink, but also okay, there we go. We are on target. That's interesting. The bleeding cyberpink didn't, it went away. All right, anyway. So we have the cyberpink. And if I turn off the cyberpink by doing the following thing, then you see that that is the block that is cyber red. Okay. So I guess we just have to do the same freaking thing. My guess is that CB is coming out too low there, right? Like we were getting green when both CR and CB were really low. So if we're getting red, that's probably CB has the same problem, right? CB. CB stands for cyberpunk, guys. Everybody knows that. So we're going to do the same ass thing we did before, but here. All right. And we need to only do this on frame 5. So now we're there. Now we're there. Decode, predict, copy. I don't know what all these operations are, but okay, so let's just look at, okay, we're going to be in the Y channel. Now we're going to be in the CR channel, I think. Or is it CB first? We're in the CR. Now we're in the CB channel. Okay, so, and we can do this in the C version just like before if we want. Odd V is 0. S of SI is 128. Well, I mean, that's like the simplest thing. What could possibly be wrong with that? Well, okay. So same thing, SI, DI. These are much high. Oh, wait. Those are actually the actual numbers. This is pretty far down in the image, I guess. 146208. So we start with 16, and we're going to put some numbers. Wait. Oh, this is different. Oh, this block. No, this is in Y right now. Okay. Or I don't understand why that's also a big number if this is the chrominance channel. Oh, because destination, not source. The source is big too. What? Oh, because this is copy. It's the same dimensions on the copy, I guess. Okay. Oh, wait. And also, we weren't initialized. Okay, I get it. I get it. All right. 36624. $255 in the red. Oh, maybe it's just the red is too high. So we do the block set. That looks fine. I don't know what the problem is. So I think I'm going to have to drop it here for a bit, and then when we come back, we're going to compare to the C version again, and just try to figure out what's different. But it's all, we've made good progress. When I woke up this morning, we basically had very little Sidney, and now we have mostly Sidney. It's just he's got, there's just some quantum noise affecting Sidney is all. This is weird because these, it's like these are adding, right? I don't know what's going on in the code. Is the code expanded wrong when it's a single instruction? No, it shouldn't be. But you never know. Like, again, we're in unknown territory. Anything could be the problem. Literally anything. Here's an interesting one. We've been doing LLVM backend the whole time. What if I do x64? Maybe it's even worse. Maybe it's fine. Oh, it's the same. That's good. But see, okay. So the reason I picked the color block is just, there might be, it seems like there might be two separate problems, right? But this color block is definitely a problem. And then here's the Y channel before the colors, and that is also a problem. So, yeah. All right, thanks everyone for coming by. We will do some more stream later today, probably, where we try to fix this. Bye, everyone. No raid this time because you can't raid every time. People take you for granted.